It is given that a piece of metal is heated to a temperature of theta and then allowed to cool in a room which is at a temperature of theta naught. Graph between the temperature T of metal and time T will be close to. So we know that according to Newton's law of cooling, the value of difference in temperature dt divided by time taken dt is equal to a constant into temperature of object minus temperature of surrounding. And with respect to time, the temperature rate of cooling is keep on decreasing, so it is not at a constant rate. Dt by dt is not equal to a constant. So if you are drawing the graph for a temperature of object with respect to time, so graph is not going to be a straight line. The temperature of object is going to change from its initial value, let's say T naught, to the final value, which is temperature of surrounding, but it is not going to decrease in a constant rate, because this is directly proportional to difference in temperature, and as the temperature of object decreases, difference in temperature is keep on decreasing. So the cooling curve will be something like this, and ultimately it is going to reach the temperature of surrounding.